Assalamu alaikum. Good morning, everyone. How are you today? Hope you are all doing well. Our lesson today is about the surface area of pyramids and cones. As you know, in the previous lesson, we took the surface area of the prisms and cylinders. What is the difference between pyramids and cones and prisms and cylinders? The difference is we will see now in this lesson. Today, we will learn and apply the formula for the surface area of a pyramid. And also, we have to learn, or we will learn and apply the formula for the surface area of the cone. Okay. Now here, as you can see, we have again two types of pyramids. Two types of pyramids. The first one is the right pyramid, and the second one is the oblique one. We call it regular pyramid, and that one is irregular or non-regular pyramid. Now here in the pyramid, it has a one base. In the prism, if you remember, we have two bases, but in here we have only one base. There in the prism, we have rectangles in the lateral faces, but here we have triangles in the lateral faces. So the lateral faces are triangles. Lateral faces are triangles here, you can see obviously, and the base can be any polygon. Any polygon. Here it is a hexagonal pyramid. Since this is a hexagon, the base is hexagon. Those are, but the first hexagon is regular, while the second one is irregular. Now this is the vertex. This is the vertex of the pyramid, and these are the two bases of the pyramids. Now we have here one difference, also another difference here, the slant height. There in the prism we have the altitude is the same as the height of the prism, but here this is the slant height. The slant height is the height of the lateral triangle. Slant height is the height of the lateral face, which is a triangle. Now, the lateral faces of a regular pyramid can be arranged to cover half of a rectangle with a height equal to the slant height of the pyramid. The width of the rectangle is equal to the base perimeter of the pyramid, as you can see here. When we open it, this one, when we open the pyramid, this is a square pyramid. When we open it, we have here four triangles. These are the lateral faces of the pyramid. Okay, now this is the side length. The side length here, if we want to find the area of all of the full rectangle, it is the base or the length all times the height or times the width, which is equal here the full sides, the whole sides of the base, which is s plus s plus s plus s, and the height is the height of the pyramid. Okay, so we can get here or guess the lateral and the surface area of a regular pyramid. The lateral and the surface area of a regular pyramid is equal, the lateral one is equal to half times the perimeter of the base times the slant height. This is the slant height in the figure, as you can see. It is the height again of the lateral face of the pyramid, which is the triangle, the height of the triangle. This is the lateral area. From where is the half? Since the faces are all triangles, not rectangles. If you remember, the area of the triangle is half times base times height, by base length times the height, and this is the slant height that we are talking about. The surface area is equal to the lateral area that we found in the previous step plus B capital. B capital, as we said before, it is the base area, the area of the base. Here, since we have one base, so we will add one B. In the prism, we added two base areas because we have there two bases, but here we will only add one base area. Now let's take the first example. The first example, find the lateral area and surface area of a regular square pyramid with base edge length 14 centimeters and slant height, the L slant height is 25 centimeters. Round to the nearest tenth if necessary. Okay. Now we write the lateral area of a regular pyramid, which is equal to half P perimeter of the base times L, which is the slant height. Substitute the numbers half times 56. From where is the 56 here? This is the explanation. It is the perimeter of the base. The perimeter of the base. The base is a square. Since it is a square pyramid, so the perimeter of the square is 4 times the side length, which is equal to 56 centimeters. And the slant height, which is given here for 25 centimeters, the answer is 700 centimeters square for the lateral area. Now the surface area is, as we said, the lateral area plus the base area. Substitute now the 700 for the lateral area that we found in the previous step plus the base area. The base area here is the explanation. The base area is side length squared, since it is again a square. The area of the square is the side length square, 14 square, which is equal to 196. So this is the full surface area of this square pyramid. Okay. As we did always, we have to solve the check it out one, for example one. Find the lateral area and surface area of a regular triangular pyramid with base edge length 6 feet and slant height 10 feet. Okay, how to find it? Of course, we will first find step number 1, find the base perimeter and the height of the base. The base perimeter is 3 times 6 equal to 18 feet square. 18 feet, sorry. So the base area is half times base times height. Now it is equal to, here the height, as you can see, the height is 3 radical 3. Look at the figure. Again, we applied the special right triangles property, 30, 60, 90. This here 3 and this is 3 radical 3. Okay, so this one is the height, 3 radical 3. We found here the base area, which is half times b times h equal to 9 radical 3 feet square. Okay, now find the lateral area. Here we will put the lateral area equal to half PL. Then we substitute 18 for the perimeter and 18 for the perimeter and 10 for the slant height. Okay, it is equal to 90 feet square. This is the lateral area. And find the surface area. The surface area is the lateral area that we found in the first step, then plus base area, one base area. Substitute now. So it is equal to 105.6 approximately. This is the surface area of this pyramid. Okay. Now move to the cone. The cone, it has one difference between the cone and the pyramid. In the pyramid, the base is any polygon. It is any polygon. We focus there on the regular polygons only, and we will find the surface area, the lateral area for the regular polygons there. But in here, the cone has a base, which is, the base is a circle. It is also has one base here, which is a circle. And again, this is the slant height, is the blue line. The slant height, this is the slant height. and this is the axis. The axis is the altitude or the real height of the cone, which we will use later on, not in this lesson. These are the vertices here. This is the first vertex. It has only one vertex for each cone. This is the right cone, and that one is the oblique one. We will also, here as we said before, we will focus on the right cone only. Okay, now for the area, the lateral area of the cone, here we will apply this formula, pi r L. R is the radius of the circle, the base, and L is the slant height. The surface area of any right cone is equal to the lateral area again plus base area, one base area here, this one, which is again pi r L, the lateral area, plus pi r squared, since the area of the circle is pi r squared. The first example about cones, find the lateral area and the surface area of a right cone with radius 9 centimeters and slant height, which is L, 5 centimeters. Apply the first formula, which is the lateral area. L is equal to pi r L, all are given. Pi, again, put pi as it is. In the last step, we might substitute. Here it is pi times 9 times 5, which is 45 pi. Substitute 9 for the radius and 5 for L. Then the surface area is the lateral area that we found in the first step, plus the one base area, which is pi r squared. Substitute the numbers, then you will get the surface area in terms of pi. And check it out too. Find the lateral area and surface area of the right cone, which is shown in the figure. Look here, we have a problem that we don't have, as you can see, the slant height. We have the altitude, the real height, which is 6 centimeters. But we don't know the slant height, this one. This is the slant height, which we need to find the surface lateral area, for the lateral area. So what we will do, I think you all think about the Pythagorean theorem to find the slant height here, this one, the shaded one. The Pythagorean theorem, as you remember, it is a squared plus b squared equal to c squared. Here, a is 6 centimeter, b is 8 centimeter, which is half of the 16 is 8. So 6 squared plus 8 squared, or 8 squared plus 6 squared, equal to L squared, which is the hypotenuse in the right triangle. We put the square root for both sides to get 100, square root of 100, which is equal to square root of 100, which is equal to 10. Here we have to put the square root. Okay, L is equal to pi r L. By mistake here we did not put the square root, but we have to put it in order to find it. Now L, the lateral area, is equal to pi r L. Pi times the radius, which is half of 16, again is 8, and times 10. Again, as I told you, we have to put the square root for this one. Okay, 80 pi centimeters squared is the lateral area. The surface area is equal to pi r L plus pi r squared. Again, we put the formula and we substitute to get 144 pi centimeters squared for the area. So here we have only one different thing, that we had to find the slant height. It is unknown, and we used Pythagorean theorem for that. Pythagorean theorem to find L. Okay. Now, and check it out. 3, for example, 3 here. Again, the effect on the dimensions, how it will affect the surface area. Now, the base edge length and slant height of the regular square pyramid are both multiplied by this number, this fraction, 2 over 3. Describe the effect on the surface area. Describe the effect. No need to find the surface area for both, only description. What will happen for the surface area? This is the original dimensions, and this is the multiplied ones, okay, by 2/3. Now, what is the effect? The effect here for the surface area, that by multiplying the dimensions by 2/3, the surface area was multiplied or will be multiplied by 4/9. 4/9, which is the square of 2/3. 2/3 squared will give us the 4/9. Okay, thanks a lot for listening and focusing and understanding. If you please try to solve the homework, which is question 3, 4, 5, 6, 8, and 9, page 693 from the textbook. Don't worry, it is easy. It doesn't need so much steps. Thank you so much.